Welcome to the Asking the Experts podcast, where every day is a good day to ask a question. This podcast is provided by the Adaptive Silviculture for Climate Change, or ASK Network, which is a collaborative effort to establish a series of experimental silvicultural trials across different forest ecosystems in the United States and Canada. In each episode, we bring you up-to-date findings from natural resource professionals who are conducting applied research related to climate adaptation and ecosystem management. We hope that platforming these individuals and their work will lead to a more widespread understanding of the importance of climate adaptive management and improved ecological outcomes in North American ecosystems. Thank you for tuning in. Good morning, all. This is your host, Riley McMillan, and in this episode, I'm joined by Dr. Martha Sample, a researcher and climate adaptation specialist with the University of Minnesota Department of Forest Resources and the Northern Institute of Applied Climate Science, aka NIACS. Martha has expertise in a variety of topics in the sectors of applied ecology, conservation, and climate adaptation. This includes fields like ecological restoration, impacts of global change, fire management, and ecological monitoring. In her current role, Martha is working to synthesize and communicate scientific information about how climate change and emerald ash borer are affecting lowland hardwood forests in the upper Midwest. Thank you, Martha, for joining me today for this interview.
Thanks for having me, Riley.
So, at the beginning of each interview, I've asked that episode's expert set the stage by sharing a bit about their experience in natural resources. Continuing that tradition, can you tell our listeners more about your history as a student and researcher and how you got involved with the work that you do now?
Absolutely. So I am from Wisconsin originally. I grew up in Madison, and when I finished high school, I left to go to the University of Montana, where I got my undergraduate degree in environmental studies. And at that time, I was focused on and a little more interested in like the human dimensions of the environmental realm and some of like the social implications. And then after I finished college, I spent the next 5 years just sort of traveling around, doing a whole variety of different seasonal jobs, including guiding wilderness trips, doing environmental education, working just in stores as like a retail sales associate, and then ultimately ended up back in southern Wisconsin working for an ecological restoration contractor. And that work was really interesting to me and prompted me to think more about graduate school. So I ended up moving to Flagstaff, Arizona for an interdisciplinary master's program that they have at NAU, Northern Arizona University, in environmental sciences and policy. And so that ended up being a really great program for me, kind of still incorporating some of those human dimensions and management implications and policy components, as well as more of the natural sciences background that wasn't as much of a part of my undergrad degree. And when I finished my master's, I stayed on at NAU working as a research staff person on a whole variety of different applied ecology and conservation projects for a small research center. Got to travel doing a lot of field work all over the Western US and even to Hawaii and Central America in some cases. It was very cool, broad experience. And after a couple years of just working, I decided to re-enroll as a PhD student at NAU. And that was sort of in a non-traditional sense. I stayed on as a staff person working and sort of did this combination of leading various research projects that became parts of my dissertation, while as a student doing some additional coursework and taking more of a leadership role on those projects, which were for my dissertation related largely to forest restoration, climate adaptation, and ecological monitoring. And it was through some of that work that I was first exposed to NIAX and the really pioneering work that NIAX has done in the climate adaptation field, and was able to incorporate and build on some of that in some of my dissertation work. So I was really excited when I graduated that there was a position open through the University of Minnesota in partnership with NIAX to work on this project, which I am now working on, which is a partnership between the University of Minnesota, NIAX, and the Forest Service Northern Research Station, and then also the Chequamegon-Nicolet National Forest in Wisconsin. And we are funded by a grant from the Great Lakes Restoration Initiative. And so that has been really wonderful and a great place to land. I feel very lucky to be working on this project, which, as you mentioned, is focused on looking at the state of both practice and knowledge in northern lowland hardwood forests and developing information resources and practical tools designed to support managers and stewards who are grappling with ways to adapt to the significant changes that have been happening in these forest types from emerald ash borer and climate change.
Great. Thanks, Martha. I'm really inspired by your journey and how you've been able to learn and work in so many different areas throughout your professional and academic career. So, today we're going to focus in on just your current project, which, as you mentioned, addresses the effects of climate change and emerald ash borer on lowland hardwood forest systems in the upper Midwest. For those who don't know, I'll just give a quick overview of emerald ash borer and its effects on forest ecosystems. So, emerald ash borer, aka EAB, is a wood-boring beetle native to Asia that's suspected to have been introduced in the US in the late 1900s. EAB adults lay their eggs in the inner bark and phloem of ash trees, which are members of the Fraxinus genus. And when the larvae emerge, they feed on that inner tissue, which damages the tree and eventually leads to its death. Since EAB's introduction, it has earned the title as the most destructive tree insect ever introduced on the continent. So it's clearly a really big problem for managers across both the US and Canada. If you're interested in the current status of EAB invasion in the US, you can check out the USDA APHIS EAB map, which I'll include in the show notes. Now, I'm not as familiar with the ecosystems that you all are focusing on, Martha, so can you describe to our listeners what a northern lowland hardwood forest is?
Absolutely. Yeah, I appreciate the opportunity to do that, since it can be really important to define what systems exactly we're talking about, and especially here where there's a ton of different terms that get used for these ecosystem types, partly because they are actually very diverse. And when we are lumping them together, we're talking about multiple individual and sometimes distinct systems. And so we have been using the term northern lowland hardwood forests to group a specific set of those ecosystems that share some characteristics. And so just to break down that term that we've chosen, northern refers to the geographic region of the upper Midwestern states that we are including in our scope. And so that's Minnesota, Wisconsin, and Michigan. And then lowland refers to ecosystems that are intermittently inundated, or in other words, have water levels that fluctuate seasonally due to precipitation and or groundwater dynamics. And the systems we're focusing on for this project are also forested. So they're not like an open herbaceous or shrubby wetland. And they're also dominated by hardwood species, so not some of the conifer softwood dominated swamp type ecosystems that do exist in our region. And that means that for this region, they also generally include a black or green ash component. And so that depends on the type of system it is. We see black ash more often, but not exclusively in those wetland forests, and then green ash more in the riparian and floodplain systems. So that's not a rule, and they do coexist in certain areas too. And so this definition ends up including forested wetland systems, as I mentioned, like black ash swamps or central hardwood swamps, and then floodplain and riparian forest systems, including some of these like really enormous floodplain systems like we see along the upper Mississippi River in Minnesota and Wisconsin, the Wisconsin River in Wisconsin, and others, but also, small tributary systems that have different dynamics, but still have some of these same species and, are also intermittently inundated. And that also can include some coastal and estuarine forests along the Great Lakes. So that is what we mean by northern lowland hardwood forests.
Awesome. Thanks, Martha. It's really interesting how such a specific definition can encompass so many types of systems. So, I'm curious, why is your project team interested specifically in northern lowland hardwood forests in the upper Midwest region? Are there some special ecosystem services offered by this system, or is it highly vulnerable to change? Is there a large community interested in these forests? What's your reason behind your focus?
Yeah, I would say both and all of those. Um, so the main reason that we're focusing on this group of systems in this region is just simply the concern that has arisen within the management community because we've been observing some really significant impacts from emerald ash borer and changing climate patterns. Lowland hardwood forests are especially vulnerable to these changes because they often have ash components, and that makes them more vulnerable to impacts from EAB. They have a larger proportion of ash trees than some other forest types in the area that EAB has impacted. And as lowland forests that sort of exist in the interface between aquatic systems and upland systems, they're adapted to fluctuating water levels, but they still have thresholds. And some of these changes, especially in precipitation regimes and flooding regimes, can really impact their persistence in their habitats. Our region of the upper Midwest also has a really high concentration of ash trees. EAB was first detected in North America in the early 2000s in the Detroit area in Michigan. And at this point, most of the ash populations have been really decimated across lower Michigan and other areas close to that epicenter of invasion. And EAB has now been detected in most counties across Michigan, Wisconsin, and Minnesota, our whole project region. But importantly, it hasn't yet arrived or been detected in some of the areas where there are the densest remaining ash stands in the upper Midwest, which are those black ash swamps in far northern Minnesota, Wisconsin, and the upper peninsula of Michigan. So, as far as EAB is concerned, this region captures both some of like the longest impacted and most impacted areas close to that epicenter of invasion, and also the active front of EAB spread. So there are managers who are both contending with the aftermath of ash mortality and managers who haven't yet experienced those impacts, but see the writing on the wall as they watch what's happening to similar systems as EAB spreads. And they're certainly all contending with climate impacts as well. So there have also been some common observed and projected climate change trends across the region that have raised concerns in these forest types. And so though there are other regions of the country that are experiencing some similar concerns with EAB and or climate change. For example, in northern New England and Maine, that's another active front of EAB spread. The ash ecosystems in that region are a little bit different. They're not always in lowland areas. And so we're really just trying to group these challenges and concerns that are being confronted by managers in a region that's both big enough so that our work can be as broadly applicable as possible, but also small enough so that we're really talking about the same type of systems and the same both observed and projected climate impact. So it's as much apples to apples as possible, though we do anticipate that, what we're doing and what we find will hopefully be useful to others outside of our region. But basically, the project is responding to manager concerns and expressed needs from managers for additional information and resources to support achieving their management goals as EAB and climate change really drastically are changing and impacting their ecosystems in these lowland hardwood forest types.
Great. That makes sense. So it sounds like you're really focused in on the threats posed by climate change and EAB, and also understanding how those have, are, and will continue to affect these forests to support local management. And it also sounds like studying this more narrow region yields more comparable results between the systems, which is super valuable. So, given the high concern in the region surrounding climate change and EAB invasion, the effects of these drivers must be pretty pronounced. I'm assuming some of the more obvious effects are tree mortality, especially of ash species, and maybe some shifts in precipitation or hydrology. Can you expand on that and share some of the ways that northern lowland hardwood forests are affected by both climate change and EAB?
Definitely. Yeah, it's pretty interesting and worth mentioning too, as I'm sure you and your listeners know, these disturbances or changes, forces of global change are interacting with one another as they individually impact these systems. And so it can be really hard to parse apart exactly what the direct and indirect drivers and interactions between all of them are. But there's a variety of ways that climate change and EAB and other global change factors are impacting these northern lowland hardwood ecosystems. As far as climate change goes, two big factors are changes in precipitation and then subsequent flooding regimes. So, in that case, in our region, we're talking about more rain in general, more extreme precipitation events where a larger amount of rain falls over a shorter period of time, and then changing seasonality of precipitation. So, that would include different amounts of the total annual rainfall falling during different seasons, especially as it relates to the growing season, where trees in these systems might be more vulnerable to water levels outside the range of what they've historically been adapted to. And that also includes more precipitation falling as rain instead of snow in the winter. And so these trends have had especially concerning outcomes in floodplain forests, especially some of our larger floodplain forests like the upper Mississippi and Wisconsin rivers, where there have been multiple seasons in recent years where water levels during the growing season have been high enough to overwhelm even the flood tolerance of floodplain tree species, resulting in sometimes really dramatic die off in the overstory. And that's something that not only scientists and managers have observed, but a lot of people recreate in these areas and there are cities along these areas. And it's just been like a really impactful thing to observe as not just ash, but many different floodplain species have sort of succumbed to these changes in hydrology. Another one is the increase in winter temperatures. And so that is impacting more of the management end of thinking about these systems. And so because lowland systems are wet and have wet soils, oftentimes they, again, historically have been managed in the winter when soils are frozen, and therefore there's less potential impact to soils from timber harvest activities or invasive species removal, anything that would require entering with either machinery or people and ideally not getting stuck in the mud. So the fact that we've had fewer days where the soil conditions are appropriate for that kind of management has really forced some rethinking about how we can do management in these systems. So that's a little bit more of maybe an indirect or management related impact, but still has been really something on the top of folks' minds when thinking about these systems in our region. As for EAB, the main effect that EAB is having across this region and as it spreads from its epicenter of detection and invasion is just that it results in really high 90s percentage of adult tree mortality. And so obviously the impacts are going to depend on how many ash trees are in an area in a stand. But when EAB comes into a system, it really results in almost total loss of the adult trees in that system. And then while ash can regenerate in areas where EAB has been observed, the beetles will re-attack saplings once they reach a certain diameter. So effectively, that prevents them from ever recruiting into the overstory. And so subsequently, you see canopy gaps in areas where ash might not be a dominant species, or like wholesale loss of the overstory in areas where it's pure ash, like a black ash swamp. And so, along with that, there's concern about changes to the water table, just with loss of those organisms that are doing work like evapotranspiration, changes in nutrient cycling as the leaf litter is lost. And I think ultimately, what is the biggest concern for everyone who's watching these impacts occur to varying degrees across the region is just the potential for conversion of forested ecosystems to non-forested ecosystems. And so the reason that we are so concerned about the effects of these changes in these systems, and part of the reason that we're already seeing such drastic changes, is that although a fair number of these systems are rather disturbance adapted, like floodplain forests, which are accustomed to big disturbance events in some cases, or at least fluctuation in those biophysical conditions. They have already undergone a great deal of change and disruption in many cases. And though they have, like I said, evolved to withstand a range of historic fluctuations, they still ultimately have thresholds. And so a shift too far in either direction, really, whether it's too wet or too dry, can really like fundamentally change the conditions in a way that causes mortality for those species. So the unique hydrology of these systems has already been stressed by prior land use practices in the region, which were very common in the past few centuries, and that includes ditching and draining of wetland areas and clearing for agriculture in floodplain and riparian systems. We saw a lot of damming and channelization, and also just things like expansion of road construction for forestry or development or agriculture can, really cause disconnection in the connectivity of especially like groundwater systems. And so that has sort of increased the underlying level of stress in these systems, as have other historical events and land uses like the period of overharvesting forests during the Great Cutover in the upper Midwest. And then also, in addition to the current pest and pathogen and forest health issues with EAB and a few others, these systems have already lost some components due to past pest and pathogen invasions, most notably Dutch elm disease, which effectively removed a majority of American elm trees from these systems, which at one point were one of the more common species. An interesting one of the potentially most climate adapted species, like some of the ash, have effectively been removed from these systems and can't regenerate due to the persistence of, in the case of DED, the pathogen, or in the case of EAB, the pest in these environments. So all of that just means that there's these heightened levels of baseline stress, which mean that the systems potentially have more sensitivity to these additional changes from climate change or EAB or whatever we're throwing at them with global change.
Thanks, Martha. It sounds like a lot of the changes experienced by these forests have been truly devastating. So much so that even the more disturbance-adapted species aren't able to survive. I can also imagine how difficult it is to address those changes when you're faced with an ever-shrinking management season. Overall, it sounds pretty disheartening, but I bet your team's work is yielding some hope for the future of these systems. So, one thing people are often most concerned about when it comes to change in ecosystems is how will this affect the ecosystem services that I care about? And for listeners who may not be as familiar, ecosystem services are resources provided by natural systems that primarily humans benefit from. That could be timber for building homes, a wetland that filters water for human use, an aesthetic place to go hiking, or habitat for our favorite animals. So, I want to ask you, Martha, based on your work thus far, are there any specific ways that you expect ecosystem services to be altered due to the changing climate and EAB over, let's say, the next 50 years?
Yeah, I think this is one of the $1 million questions, and it's one where there is still a lot of uncertainty. And so I'm not totally sure. It's also a case where we have already observed a lot of change. And obviously, as I mentioned before, it's hard to separate climate change from a lot of these other changing disturbance regimes that we're dealing with. And these really are, I should mention, active areas of research that many in our region are engaged in, especially in areas close to that epicenter of invasion in lower Michigan. A lot of folks are looking at observed ecosystem responses and changes in those services in areas that went through, complete ash mortality and loss at this point, 20 years ago or so, and beginning to evaluate what are the changes in all aspects of ecosystem structure and function and composition. So there's a lot of stuff that's actively happening and coming out both to document what we've observed and think about what that might mean as EAB continues to spread and changes in climate continue to accumulate and accelerate in some cases. It's also, I think, this question is one where it's hard to kind of generalize across the broad suite of specific ecosystem types we're looking at because of that complexity and site specificity that I mentioned earlier. So even when we see research results from a study that has been conducted in, northern Indiana, it's hard to infer what that might mean for a black ash swamp in northern Minnesota. So it's a little bit hard to say on a broad scale exactly what we would expect, but we're also lucky enough to have some research and experiments being done in multiple different systems. So there are, even in those black ash systems that I mentioned, that are still sort of at that forefront. They haven't been totally hit and affected by EAB yet. There have been multiple research groups from Forest Service Northern Research Station in Minnesota and Michigan Technological University in the Upper Peninsula who have done some really interesting experiments simulating mortality from EAB and looking at what that might mean for their systems. So I think that there's some interesting approaches that people are using to understand more fully what these impacts might mean in areas where they haven't occurred yet, and also kind of quantify and assess in areas where they have happened. So there certainly have been and will be changes, but it's hard to say exactly what. I think that one example is black ash in areas, especially where black ash is dominant or the only species in a forest. Black ash is really unique in a variety of ways, and so really serves as a foundation or keystone species, both ecologically and culturally in systems where it exists. This is because it has really unique physiology, and so ecophysiologically, it has a high importance. It has really high rates of evapotranspiration, meaning that it's able to function sort of as a pump, and all trees do, but this is a very effective pump. So it's moving a lot more water than other trees from its roots up to its leaves and back into the air, which effectively can lower the water table during the growing season when the leaves are out, which literally, is changing the characteristics of the physical environment that it lives in and is directly influencing which other species, both other trees that are maybe growing with it or understory plants, can grow because, different plants have different preferences and tolerances for soil saturation and depth to water table. And then subsequently, what animals are there and the whole makeup of the larger ecological community. So it really kind of not only is a member of those ecological communities and forests, it really shapes them. And so losing black ash is a big concern because there's not like an easy replacement species that fills that really unique ecological niche. And then culturally, it also has like a very important role for indigenous communities in this region and really across the entire region where black ash grows. It's also called brown ash in New England and Maine, where indigenous communities also place high value in this species. And among other things, black ash is used for traditional basket making by indigenous people. And the specific qualities that make ash really special and a prized material for basket making and other uses are, again, characteristics that other species don't necessarily have. And so culturally, it's also one of those things where it's not like, oh, if we lose the black ash, we'll just start using green ash or we'll start using oak or something. It doesn't really work that way. So it is very unique. So that's a case where there is a lot of concern around those specific ecosystem services. And like I mentioned earlier, I think a big concern is that potential for conversion to non-forested wetlands, especially in areas where ash is the dominant species, and the loss of trees and just forest and the ecosystem services that are associated with forests as opposed to other ecosystem types. But I do want to mention, as a person with background in not only forests, but many other vegetation types and ecosystems, I think we need to keep in mind that this doesn't necessarily mean that there are no ecosystem services from other ecosystem types. It just means that they are different. It doesn't mean that there's no wildlife habitat. It just might be suitable for other species. And that doesn't mean we shouldn't be concerned about it, but it just is, I think, important to think about the context and potential for not necessarily loss, but change of what ecosystem services we're looking at. We're 100% sure they will change, but we don't necessarily know exactly what that will look like.
Thanks, Martha. I really appreciate your outlook on that losing forest isn't a total loss, just a change in the services that ecosystem can offer. I also like how you provided the example of black ash and mentioned some of the physical services it provides for its ecosystem cohabitants, in addition to the cultural services it provides to indigenous communities in the region. So, in the case of black ash, you mentioned that there's not really a species managers could plant that would functionally replace the ash in those stands, at least in all of the ways that it benefits those stands and the people around them. So, aside from just sourcing and planting a perfect replacement, are there any pathways for adaptation that you or your team have identified for this species and for the others present in these ecosystems? If so, how can or are these pathways being implemented in the region?
Yeah, absolutely. That is the big question and the hard question, and the one that we're here to tackle. So there's not, like a one-to-one replacement for black ash, but that definitely doesn't mean that we have no options and that, it's a foregone conclusion that those areas will convert to something else. It just means that it's, I think, a little bit more challenging in this case to think about what maybe suite of species you might need to use or different structural goals or whatever you might need to use to achieve some of those outcomes that you're looking for. So, with that in mind, it's worth mentioning that pathways and strategies for adaptation are always going to depend on those individual and specific values and goals and site circumstances of a particular management organization or agency or an individual manager or a specific project, even thinking about that site to site variability. And so pathways are definitely going to depend on like what you're hoping to achieve. If it is just, that it's most important that there be a forest there, then that's going to influence what you're attempting. But as far as what we've been learning, we and I have been just mostly learning a ton from practitioners, from the managers and stewards and applied researchers that we have been in touch with and partnering with throughout this project. So partly I mentioned that because it definitely, like you use the word identified, and it's more like identifying as opposed to like we're not inventing anything. We're just sort of collating and summarizing the things that the practitioners are actually doing. They're the ones who are doing a lot of the innovation, I think, in this space. So we know from looking at a lot of examples of projects that are actually happening that concerns about change and objectives for management vary. But as you mentioned, I will say it does seem like a common thread in pathways that are actively being pursued that folks are looking to find ways to replace trees that have been lost to EAB or flooding in those floodplain systems. So it's not always ash replacement, but it's just, looking for ways to promote forest cover, even if species composition is changing for a variety of reasons, for concerns about ecosystem services or specific values that people are trying to manage for on the landscape. So we, as part of our project, we conducted a review of both operational management project and applied research case studies. And that review and sort of the summary and interpretation we've been doing has suggested that practitioners are really testing and applying a ton of different strategies in their operational work. It's really cool to see the creativity and willingness to experiment and in some cases take risks that we're seeing, not only in research, but also within the management community. And a lot of that is being done to either promote natural regeneration and or look at options for artificial regeneration through planting or seeding work. And we've seen that there have been really highly varying degrees of success. However, differently success might be defined for that individual case. But there is a lot of uncertainty there still. We believe that a lot of that, again, is due to that high site specificity where folks are, in some cases, using the same techniques but getting different results. But we're also seeing that a lot of the cases are using unique combinations of different methods, which then are a little harder to parse apart, like what is the causality between the action and the outcome, or the site characteristics and the outcome. So we've definitely identified that it's very important to understand as much as possible about not only what management occurred or treatments occurred, but also what those unique site characteristics are when we're trying to figure out what is driving the outcomes that we're seeing, whether they're desirable or undesirable outcomes. So there's a couple of things that have kind of risen through the uncertainty, including there's been a high level of success with planting swamp white oak across systems, which I don't think will be a surprise to any listeners that are working or living in our region. But we also have cases where people documented high levels of success with a species in one case, and then a different case documented a really undesirable result from that same species. And so the way that I've been thinking about that as far as like what options or pathways we have identified is not that like we throw our hands up in the air and say like, well, this is all over the place, like who knows? It's that it's really important when thinking about, planning a future project and looking for information on what might be most effective to really think about what the exact treatments and the site characteristics were that may have contributed to a specific outcome, and to understand that there are different outcomes in different systems. So we can't necessarily make an assumption or an inference about what's going to happen in our next project based on one or a small number of examples. So I think that though it's a little bit frustrating that we don't have like a list of 10 things that we can say everybody should do these things, or people in black ash swamps should do these things, people in floodplains should do these things. I think that we have started compiling information in a format that can help individuals identify the best available information that they can then consider thoughtfully when thinking about what will work for them in their unique situation.
Thank you, Martha. Yeah, people are frequently remarking on how it can be frustrating that there's just not one broad answer, and I agree that it would be so much simpler. But I do appreciate how your team is taking time to listen to and compile many possible answers and make them usable for folks. And I really like how you pointed out that you are just identifying and learning from, mostly, what managers already are doing in the region. It's quickly becoming a theme of the podcast that the folks on the ground who are directly and intimately involved in stewarding these systems really possess this wealth of knowledge that folks in the research world simply could not perform their work without. And I think it's really important, and I'm sure you agree, that we really praise the management community for their hard work and dedication in keeping these systems up and running and alive for all of our benefits. So, moving on, from what I know, it sounds like the next steps for your project, as you're working on synthesizing this information, is sharing it out to folks who need access to it. Given that, are there any resources, including those that your group are creating, that you would recommend to managers of northern lowland hardwood forests who are interested in performing climate adaptive management?
Yeah, you're spot on that that's sort of where we're at is like, well, what do we provide based on the early conversations we've had about needs and knowledge gaps or resource gaps that may exist, and understanding as we've come to learn throughout this process that I think at this point, a large amount of the information really does lie within those management and stewardship organizations and individuals and the practitioner community. There are resources which I think a lot of those folks are already using and know about, like guidelines for ash and EAB management that have been developed by state agencies like Wisconsin and Minnesota Departments of Natural Resources, and also resources that folks in the region might be familiar with, like the Great Lakes Silviculture Library, which is a source of case studies that we drew from for our review and summary, and also university extension programs. At Minnesota, we have the Sustainable Forest Education Cooperative, which does a lot of kind of symposia and field days that help managers connect with other managers and with researchers to understand the real challenges that are being faced on the ground and to look at different strategies and operational treatments that are being pursued on a whole variety of issues, not just this one. But to supplement that, what our team is currently working on is to turn the review of case studies that we have done for this project into a tool that we hope will, at the very least, connect practitioners with the knowledge of other practitioners who, maybe they have these in-person opportunities to connect at a field day or an event, or they run into each other just as colleagues in, a similar geographic area. But how can we help connect people who didn't attend the most recent field day or who live in states that are too far apart to run into each other at, the gas station or whatever it may be and talk about what they experienced. So given the kind of wealth of information that we think is contained in these operational case studies, we have basically a database that we've compiled of that sort of documents the different site characteristics, descriptive aspects of the project, like where is it and who is managing it and how big is it? When did it start? Those sorts of things, as well as the specific management techniques that were used that we're aware of in the project. So things like, did the project involve harvesting trees? If so, what silvicultural systems were used or what techniques were used? Did the project involve planting or seeding? If so, what species were used and what methods were used for planting or seeding? Like what tools were used or what season did it occur? Kind of the specific details about that. And then also information about how any follow-up monitoring was conducted. So like what characteristics or variables or indicators were measured to evaluate the outcomes, including simply, just like visual checks for regeneration. We're not limiting that monitoring to like quantitative formal measurements. And then in a broad sense, like were the outcomes of the project desirable or undesirable or kind of mixed, or in a lot of cases, we just don't know for sure based on the documents we were reviewing because we don't know necessarily what exactly those desired future conditions were. And unless the case study contained some sort of assessment of whether or not those outcomes were perceived to be successful or not, we don't necessarily know. So it's not a perfect system, but it sort of gets at creating categories for all of these different components of a project that then if you standardize them and lump them like in the spreadsheet format, it can be a searchable, filterable thing. So we're viewing this tool as sort of a resource that practitioners or researchers could use to more quickly identify examples or case studies that are the most relevant to a question they may have or a technique that they're interested in trying, or simply like what's successful. Like I'm interested in having a successful outcome, and this is, the characteristics of the site I'm working in, and with the understanding that outcomes are variable, I really only want to look at what's been successful in floodplain systems, for example. If that's where I'm working, I don't necessarily want to know uh, what's happening in a totally different ecosystem type. And so we're working on getting that set up as a interactive web-based tool in partnership with the Great Lakes Silviculture Library, which is based out of the University of Minnesota, so that essentially all the work that we've done, sort of just compiling really the information from management projects and applied research studies, would be available to the management and practitioner community to ask the specific questions that they may have of that data. And also we're hoping that folks will find it useful and that may prompt them to be interested in providing more information about additional case studies. We know there's a lot more happening out there than we were able to find public documentation for. So we're hoping to expand the number of case studies and management projects that are included in that database so that, again, it's as kind of robust and powerful as possible as a tool without overstating that it's not the type of information that can be formally analyzed. But again, I don't think that means we need to throw up our hands or say we can't do anything useful with it. I think it just means we need to be careful in how we interpret it and the inferences we make from it. But I think that given it is some of the best information we have right now, it's hopefully useful to just increase the visibility and the accessibility of that information.
That's super cool. Thanks, Martha. Having seen the beginnings of this tool, I can share that it is a really impressive undertaking, and I believe that it will be an awesome resource for people involved in this work for years to come, once it's been finalized. So I think that brings us to the end of our time, and we've ended up on a pretty upbeat note, but I recognize that sometimes these topics can be heavy or maybe a little bit disheartening, like I shared earlier. So, in closing, I've been asking the day's guest to share something that makes them optimistic in their work. So, to you, Martha, is there anything that makes you optimistic about the future of northern lowland hardwood forests or natural resources in general?
Yeah, definitely. And I appreciate the opportunity to think about some of those more hopeful aspects. And I think that I definitely feel hopeful or optimistic about the potential here, despite like the super significant and sometimes like really difficult to process and accept like losses that we have experienced, we are experiencing, and we almost certainly are going to continue experiencing, which are pretty overwhelming and kind of have less uncertainty in a way about like really the degree of loss that we're facing. But I have been really inspired by the action that that has prompted within the management stewardship practitioner community. Like this is maybe because it's quite like visually dramatic sometimes and shocking, like it really has resulted in interesting and innovative work that's motivated by that concern, I think. And so it's been really, really cool to see the willingness that folks have and have had to just try new things or do something experimental on a small scale or just take a risk that maybe they wouldn't have felt as comfortable taking if it didn't feel quite so urgent. So that definitely is inspiring and gives me hope. And I also think that kind of an inherent part of the uncertainty that surrounds a lot of this work related to the future in general or disturbance or climate change is that we talk a lot about how we can't anticipate and we're concerned about like potential unforeseen consequences or vulnerabilities or sensitivities that come up based on these like weird interactions or complexities that we don't understand. But I think that part of uncertainty is also maybe thinking about or can be thinking about the unexpected adaptive capacity that our systems and species will show, which is not to say that there's going to be more of those than the negative things, but I think that, and it is important to think about and acknowledge and like not underestimate some of the threats of the uncertainty surrounding these things. But I think we often, it just completely overshadows the fact that there's always going to be like uncertainty related to more positive, though unexpected things that could happen too. So like there's another side of that coin of uncertainty that I think gets kind of underappreciated or under acknowledged sometimes. And that gives me hope too, just when I think about all the things that could go wrong that we don't know about. It's that, there's just things, period, that we don't know about. And we don't always know if they're things that present more challenges or things that are more like a good mystery.
Great. Thanks, Martha. I really like your perspective. Who's to say that there aren't just as many possible positive things that could happen at any given place or time compared to negative things? It's really good to remember that there are good things happening as a side effect of change as well, because I agree, sometimes we just forget about those. This is a small tangent, but some good news I heard this week is that the saiga, an endangered Eurasian antelope species, is now thriving in Kazakhstan, due to some pretty incredible conservation action over the last few years. And that got me really excited, just for the future. So let me know in the comments if there are any other saiga fans out there. But anyways, thank you so much, Martha, for coming on the podcast today. Before we finish up, is there anything else that you'd like to share with our listeners?
You're welcome. Seriously, thanks for asking me. I think the only thing is that if you are involved in management, stewardship, applied research related to northern lowland hardwood forests or species, and you'd like to learn more about our project or share your experiences with us, create more case studies for our database tool, please feel free to reach out to me. My email is msample@umn.edu, and I'm sure that'll be available also in the notes or associated documentation. So appreciate the opportunity to share a little bit more and maybe recruit some new participants.
Thanks for using that pun. I've been waiting for somebody to capitalize on that. And I hope that people will reach out to you and your team to learn more about getting involved in the awesome work that you're doing. Thank you again, Martha, for coming on today. And thank you to our listeners for tuning in and supporting this podcast. Stop by in 2 weeks to hear from Dr. Courtney Peterson, who is the Ask Network Program Manager, as well as a Research Associate in the Forest and Rangeland Stewardship Department at Colorado State University. Our topic's not yet determined, but I'm sure it will be super interesting, so I'm excited to talk with you all next week. See you then.